Alright guys, this is number 3 now. So this is counting the example from class or in the video, this is the 4th time you've seen this now. This should be getting a little bit more comfortable. Alright, but what we're going to do is we're going to solve a system of quadratic and linear through substitution and graphing. Alright, now just like in the other 2 videos, I'm going to do substitution first. So if you're fine with substitution, then you just skip it. You don't need to watch it. Alright, so we're just going to go ahead and substitute first. First thing we do when we do substitution is we get one of the variables all by itself. Isolate the variable. And oh, look, the y is all by itself. And so the y is already by itself. So y is equal to x plus 4. That means in the other equation, anywhere I see a y, I can just put x plus 4 instead. So I'm going to rewrite the equation. I'm doing substitution here. I'm putting x plus 4 in for the y. So I got x plus 4 equals negative x squared plus 2x plus 10. Now, at this point, I notice that it's a quadratic, which means I don't want to get x by itself. I actually want to get everything over together so it's equal to 0. Now, in some cases, we would take the x and 4 and move them over. But you know what? I don't really like negative x squareds. That just kind of makes a mess of stuff. So I'm going to go ahead and add x squared to both sides, which means I'm going to subtract the 2x, and I'm going to subtract the 10. So I'm going to move all that stuff over. So I'm going to end up with an x squared. X minus 2x is minus x. 4 minus 10 is negative 6. And then on this side, everything's going to whoop, 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 all cancel out to equal to 0. Now I've got a nice little trinomial here, which is equal to 0. Trinomial is going to be easy, right? Because that's going to factor. So we're going to go factor just like this. And I go x and x. And it's a negative, so it's got to be a plus and a minus. And with the plus and minus, say, well, 6, it's got to be 1 and 6 or 3 and 2. I got a negative x here, so let's go ahead and try for the 3 and the 2. X times negative 3 is negative 3x. 2 times x is plus 2x. I put 2 and 2 together, or 3 and 2 together, and I get negative 1x, which is what it should be. See, it matches that right there. And so now I can go, because I got 2 things that multiply together equals 0, one of those things got to equal 0. So either x plus 2 equals 0 or x minus 3 equals 0. I subtract 2, and I get x equals negative 2. And I get plus 3. I now got x equals 3. So we just cruising along. X equals negative 2 and 3. And now what do we do? Oh, sorry, I was waiting for you to answer. I can't hear you. So now that I got x, I need to find y. So I put those back into the equation. The easiest way to do that is back into the linear. So when x equals negative 2, it'll be x equals negative 2 plus 4. Y equals 2. So when x equals negative 2, y equals positive 2. And then on this one, I put 3 in. So I'm going to go y equals 3 plus 4. 3 plus 4 is 7. So when x was 3, y was 7. So there you go. Those are my answers. Negative 2, 2, and 3, 7. Those are the 2 intersections of those 2 lines. Not so bad by substitution. We're getting a little more comfortable with this. We're getting used to the idea that we just got to move everything over, make a quadratic, factor it, and solve it. Once we solve it, we put the numbers back in, and we get y. Not so bad. So now, again, we're going to go and rewind everything, because we're now going to do our favorite graphing. Just like that. So we're going to go ahead and graph. And to graph, I'm going to do the linear one first, just because it's easier. So I'm going to go to my y equals mx plus b, already in that format. It doesn't have, it may not be in this format. You may have to rearrange something, just so that you're aware. I may have it in a different format, and you have to get into y equals mx plus b form. That is fair game. All right, so b is 4, so I go to my y-intercept of 4, and then my slope of 1, so up 1 over 1, up 1 over 1, up 1 and over 1. And then I'm going to go back the other way. Yes, I'm singing a lot today because I am stinking tired. I understand how you feeling. You don't understand how I'm feeling, because you don't have a 1-year-old daughter that was up half the night crying because you went in her room and then you had to sleep on the cold floor next to her and hold her hand. Yeah, that's what Daddy does. Anyway, we got to now graph our quadratic. So we're going to graph a quadratic. Y equals negative x squared plus 2x plus 10. So vertex first. Vertex is at, or I guess axis of symmetry, I'm sorry, at x equals negative b over 2a. So I've got negative 2 all over 2 times negative 1. Hopefully you're getting comfortable with this by now, but ax squared plus bx plus c. So c is 10, b is 2, a is negative 1. So I put those in. I end up with negative 2 over negative 2, which is 1. That puts my asymptote right here. And we got our asymptote at 1. We go ahead and we put that back in because we want the y value. The y value of the vertex. The quadratic has a vertex, the linear does not. So I put it back in there. So y equals negative 1 squared plus 2 times 1 plus 10. If I am doing this correctly, that should be in parentheses. Not the negative. The negative was already there. The number I'm substituting goes in parentheses. That would be x equals 1. So that goes in. And so then I work it out, so that will be y equals negative 1 plus 2 plus 10, which is 11. So when x was 1, y was 11, so that's my vertex, and you say, but about it, that goes out the graph. Okay, well, sorry. I don't know what else to say other than that. Sorry. It goes off the graph. Go ahead, make an 11th point. It's not that difficult. If you got like 16, okay, either you messed up or I messed up. But 11, we can just kind of say, okay, let's let it slide. Just let it go. It's okay. Now we're going to go for x-intercepts. And I know this time that I'm going to have x-intercepts because see the negative in front of the x squared? That means it's going to be an upside down u. And the upside down u will have a vertex up at the top, which is right here, so it should be coming down something like this, right? So eventually it's going to go down and cross that axis, x-axis. So let's go ahead and find the x-intercept by making y equal to 0. So I'm going to go 0 equals negative x squared plus 2x plus 10. I really don't like having to deal with that negative x squared, so I'm going to multiply everything by negative 1. 0 times negative 1 is 0. Negative x squared times negative 1 is x squared. That would become a negative 2x, and that would be a minus 10. From there, we can factor. And if you don't know how to factor, then you should either watch a video on factoring or watch my music video on factoring. Or not. And then we go from there and we say, well, 10 is 5 times 2. So I try that. I go, okay, well, let's try minus 5 and plus 2. And I see that I got a 2x and a negative 5x. So negative 5x and plus 2x is negative 3x. Ooh, that's no good. That's no good because I got a 2x there. That's not going to work. So what does that mean? Well, that means it's probably, well, I could try 1 and 10, but okay, let's be honest. If 2 and 5 don't give me the 2, 1 and 10, those are farther apart. It's not going to give me the 2 either. What that means is that it's very likely that the x-intercepts here are not nice x-intercepts. So what does that mean? I'm going to have to use a quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we got x equals, now b, remember, was 2. So actually, it doesn't really matter. You could do this one or that. I'm going to go ahead and go back. Since I'm doing quadratic formula now, it doesn't really matter. I'm going to go back to the original. It's a little bit safer. So b is going to be 2. So negative 2 plus or minus square root of 2 squared minus 4 times a, which was negative 1, times c, which was 10, all over 2 times a, which was negative 1. So then I've got x equals negative 2 plus or minus square root of 4 plus 40. Negative 4 times negative 1 is positive 4 times 10 is positive 40, all over negative 2. Which brings me to x equals negative 2 plus or minus the square root of 44 all over negative 2. And I'll be honest, I have no idea what the square root of 44 is. So I'm going to type it into my handy dandy calculator. So I'm going to go 2 plus the square root of 44 that didn't do what it was supposed to. Just kidding. 2 plus square root of 44 equals, and then I'm going to divide it. Oh, it's supposed to be negative 2. Man, I'm such a dunce. So negative 2 plus square root of 44 equals, divided by negative 2, and I get negative 2.32. And then we go negative 2 minus the square root of 44, again divided by negative 2, which is 4.32. And those are my x-intercepts. So I go ahead and put those down. I go to 1, 2, 3, 4.32, which is about 4 1/3, and negative 2.32, so 1, negative 1, negative 2.32. Notice that those are symmetric, right? This one is 1, 2, 3, and about 1/3. That one is 1, 2, 3, and about 1/3 from your central axis there. So I've got 1, 2, 3. We can go ahead and put on our y-intercept now if we want. So I go y-intercept when x equals 0. So I put 0 in, I get negative 0 squared plus 2 times 0 plus 10, and I get 10 for my y-intercept. So I can put that down, reflect it to the other side. All right, so there we go. So I now have my quadratic, which looks something like this. All right, and then this one, which will go down something like this. All right. Now, my guess is that it probably crosses somewhere around these 2 points. All right. Assuming that Mr. Bywater made this a nice question, there's always a way to check that, which is by just putting in the number. So if I put 1, 2, 3, if I put 3 into my quadratic, let's just check it out because I can. So I go y equals negative 3 squared plus 2 times 3 plus 10. So I got y equals negative 9 plus 6 plus 10. Negative 9 plus 6 is negative 3 plus 10 is 7, so y equals 7. So when x was 3, y was 7. X was 1, 2, 3, y is 1, 2, 3, 4, 5, 6. Oh, look at that. That's that point right there. Oh, look at that. It's the same thing as I got for substitution. And then again at negative 2 was my other guess. So if I put in negative 2, then I got y equals negative 2 squared plus 2 times negative 2 plus 10. So this would be y equals negative 4 minus 4 plus 10. Negative 4 minus 4 is negative 8 plus 10 is 2. So when x was negative 2, y was positive 2, negative 2 positive. Oh, look at his right there. And oh my goodness, look at this, the same thing as we got right there for the substitution. So anyway, there you go. This one was a little bit more difficult to pick out the points. If you've already done substitution, then yeah, you could probably cheat a little bit and just kind of make sure that it goes through the appropriate points. You could reflect them over. You can also, like I did, you can just take x values, substitute it in, make sure that you get the appropriate values for y, the values that will match up with the graph. All right, so there you go. That was number 3. All done. You got one more to go.